In this tutorial, we're going to take a look at factoring a trinomial of the form x squared plus bx plus c. Of course, the variable can be something else besides x. What makes this different than another video I'm going to do is that this is a coefficient of 1 for the quadratic term. It's a 1x squared or 1w squared or 1m squared, whatever the variable might be. It is a little bit different, and there are other methods if there's not a 1 there. But you cannot use this method if it's not a 1x squared or whatever the quadratic term is coefficient. So factoring a trinomial such as x squared plus bx plus c means to write the trinomial as the product of two binomials. And so we're going to take a look at factoring the trinomial x squared plus 5x plus 6. And I'm going to use algebra tiles. They're a physical representation of what this looks like. It's an area model, and then we'll get into just some algebra examples on the second page. So to factor x squared plus 5x plus 6 using algebra tiles really means to arrange an x squared, 5 x's, and 6 unit tiles. And so this is what they look like. So this is the x squared tile, so it's supposed to be at dimension of x by x. The length and width are both x, so that would have an area of x squared. So if you haven't seen, whoops, I did not mean to do that. So if you haven't seen algebra tiles before, and I'll get into that one in a moment there. So this is the x squared tile, because this dimension is x, this dimension is x, length times width, x times x gives you x squared. These are the 5 x tiles because this is a unit of 1, this is x, 1 times x is x. So each of these are x's to make the 5x. And each of these are 1 by 1 tile, 1 times 1 is 1, so those 6 ones makes this 6 right here. Now, well, let's get rid of that writing. So what we're trying to do is rearrange these to make a full rectangle. Obviously, this is the full rectangle right now because this is kind of jutting out here. So I could rearrange them, and maybe I'll put one of the x's here. Okay, so this guy's gone, and then I could fill in the ones here. So there's a 1, there's a 1. There's a 1, there's a 1, and there's 1, but I got 1 left over. It's not a fully arranged rectangle. Okay, so the only way to actually do this, so there's my x squared again, is to put 3 here and 2 below. And then you see here, we would get to fill in the 6. So it has to be 3 on one side, 2 on the other, and then there's the 6. Remember, we had 6 ones. There's 6 ones right here. And then that makes a fully filled in rectangle. So what we're looking for now is what the length and width of this are, and those will actually be the factors. So across the left side here, that's an x, and then we have a 1 here and another 1. And then this is an x length across here, and then a 1, another 1, and another 1. So we would call this dimension across the top x plus 3 because it's x plus 3 more. And on the side here, this is x plus 2 more. So the two dimensions are x plus 2 and x plus 3. So that's why x squared plus 5x plus 6 would factor into the product of x plus 3 and x plus 2. And it doesn't matter which you write first. If you want to write the x plus 2 here, the x plus 3 here, it doesn't matter. You can always check factoring by expanding. So for example, if I multiply x by x, and some teachers use the acronym FOIL, first, outside, inside, last. It's just a way to remember to multiply every term in one by every term in the other. So that product gives me the x squared. Now, this product right here is 2x. This product right here is a 3x. And you see 2x and 3x add to 5x. And then 3 times 2 gives you 6. Okay, so that does expand out to give me my original trinomial, so those must be the factors. So basically, in order to factor this, the reason that 3 and 2 work is because, you see, the 3 and 2 are enough to make a 3x here and a 2x here, which added to the 5x. See, 3 and 2 are the right numbers because 3 and 2 add to 5, just like the 2x and 3x add to 5x. So 3 and 2 add to 5, and they also, 3 times 2 multiplies to give that 6 in the end. So when I'm factoring this trinomial, I'm looking for two numbers that have a sum of this coefficient. Okay, the sum of the two numbers is 5, not 5x. Okay, when you expand out the terms of 2x and 3x, they add to 5x. But I'm looking for two numbers that have a sum of 5 and a product of 6. That's what I'm trying to do. See, that's the reason I couldn't do the 1 here. To make this, see, that would be x plus 1. And then, remember, it ended right here. So this would be x plus 4 across here. Remember, I had the one little square, this guy left over. See, that doesn't work because, first of all, 1 multiplied by this 4 doesn't give me 6. Okay, so it just doesn't work. So that's why the x plus 3 and x plus 2 work, because they're the correct numbers that give this is the sum and this is the product. So on to examples on the second page here. So factor each of the following. So x squared plus 7x plus 12. In order to factor this, I'm looking for two numbers from my binomials that have a sum or add to 7 and that multiply to 12. So they add to this number here, the coefficient of the linear term in the middle, and they have a product of 12. And the only numbers that do that are, well, actually, there are more pairs of of numbers that multiply to 12. But 3 and 4 are the numbers that also add to 7 and multiply to 12. See, I could look at other numbers. Well, what other numbers multiply to 12? Well, 2 and 6. Okay, but you see, the problem with 2 and 6 is it adds to 8, not 7. We could think, well, what about 1 and 12? They multiply to 12, but you see, it doesn't add to 7. So that's why neither of those products work, and the 3 and 4 does. So the 3 and 4 do, so that's why the factors would be x plus 3 and x plus 4. And again, I can check to make sure my factoring works. X times x gives the x squared. See, this product would be 3x, and this product is 4x, which adds to 7x, and 3 times 4 in the end multiplies to 12. So that's how I know that that is correct. B, x squared plus 11x plus 18. So I'm looking for two numbers that add to 11 or have a sum of 11 and have a product of 18, multiply to 18. And again, there's lots of pairs of numbers multiplied to 18. But 2 and 9 are the only pair that also add to 11. Okay, we could think of, well, 3 and 6. See, 3 and 6 don't add to 11. 1 and 18, but that doesn't add to 11. But 2 and 9 do. So 2 and 9 do, so x plus 2 and x plus 9 would be the factors of x squared plus 11x plus 18. And again, we can check. X times x is x squared. This product right here is 2x. This product right here is 9x, and they add to 11x. And of course, 2 times 9 gives us the 18. So just by multiplying out, we can see that that does work. So we're good. For C here, a squared plus, and I don't normally write the 1. I would normally write a squared plus a minus 20, but I'm writing the 1 because there's a coefficient of 1 there just to draw your attention to it. So the two numbers have the sum of 1 or add to 1 and multiply to negative 20. So the only numbers that do that would be 5 and negative 4. So 5 and negative 4, 1's positive, 1's negative. So you see, if the product is negative, 1 has to be positive, 1 has to be negative. Think of your integer rules. And those two numbers add to positive 1. So that's why a plus 5 and a minus 4 would be the two factors of this trinomial. For a D here, w squared minus 8w plus 15. So we're looking for two numbers that add to negative 8 and that multiply to 15. Now notice in this case that the product is positive, but the sum is negative. And if you're thinking of two numbers, okay, two numbers that add to a negative and then multiply to a positive, the only way that can work is if they're both negative. See, a negative times a negative is a positive, and a negative plus a negative gives a negative sum. So the numbers that work for that are -3 and -5. They add to -8, multiply to +15. So the factors of this trinomial would be w minus 3 and w minus 5. Now what's a little bit different about e is it's an x to the fourth. Notice these are all x squared, a squared, w squared. Okay, and notice that the squared, that exponent is double this one. See, that exponent is double. There's a 1 here, there's a 1 here, that's double. So the same is true here. Okay, I have a 2 here, and this one is twice as big. Okay, so the pattern is still the same. You see, if I was going to factor this, let's say, I'm going to write this above here. So let's say instead it was x squared minus 3x minus 10. If I was factoring that, I'd be looking for two numbers that add to -3 and multiply to -10. And of course, the numbers that do that would be -5 and +2. They add to -3 and multiply to -10. So then this would factor into x minus 5 and x plus 2. And remember, I said we can always check the factoring by multiplying. X times x gives you the x squared. That -5x, this positive 2x adds to -3x, and -5 times 2 is -10. So now, the only thing that's different here is I have a 4 here and a 2 here instead of a 2 and a 1. So you see the product at the beginning here have to multiply to x to the fourth, not x squared. So each of the binomials has to start with instead an x squared. X squared times x squared is x to the fourth. And you see this is an x squared term in the middle here. So this product right here is -5x squared. And this product in the middle here is a positive 2x squared. And those two would add to -3x squared. And just like the one above, -5 times 2 does give you -10. So so it doesn't always have to be an x squared at the beginning. Okay. So if this is a 4 here, you see basically these are always half. Just like 1 and 1 are half of 2, or 1 and 1 add to 2. If that's a 4, these have to both be 2's. Okay, and in order for that to work. So so that's how this one's a little bit different. I mean, if I had a 10 here and a 5 here, okay, so then these would have to both be 5's, because 5 and 5 would add to the 10. Now, what's a little bit different in the very last one is that notice they all have x's, okay, and it's an x cubed, so 3, it's different because these are all even up here. So one thing you should always remember in factoring is always look for a common factor. I was focusing on the trinomial factoring here, okay, but lots of times there's more than one kind of factoring and something you want to put in a factor form. So there's a common factor of x in all this, so we can factor an x out. And remember, you factor an x out because there's my common factor of x. The way you get what's in here is by dividing each of these by x. So if I divide x cubed by x, I get x squared. Divide x squared by x, I get just an x. And divide this by x, I get the -56. So let's get rid of my writing here. So now I need to factor this. And I'd be looking for two numbers that have a sum of -1 and a product of -56. And the numbers that do that are -8 and 7, or 7 and -8. Okay, the 8 has to be negative because it adds to -1. The sum is -1. So the factors, and don't forget your common factor of x out front here, it'd be x minus 8, and x plus 7. Now I want to draw your attention to one thing before I finish here in F and C. In both of those, the coefficient in the middle was really close to 0. This is 1, that's a -1. Okay, and notice in both cases the two numbers are very close to being opposites. So especially when you see something like that, and this is a fairly big number, okay, so it was -56 in that one there, then what you're looking for is numbers that are very close to being opposites. So, look for 56 and 20 aren't perfect squares, but you're looking for two numbers that are close to being the same number but opposites of each other, like 5 and negative 4 or negative 8 and 7. Okay, so if you have a sum that's really close to 0, that's the kind of thing that happens. And I'll write out one example at the top here. I got a little bit of room. So let's say, here's an even bigger one. Let's say we were asked to factor x squared plus x minus 90. Okay, so the sum is 1, that one there, and negative 90 is the product. So the numbers that do that would be 10 and negative 9. Again, close to being opposites. 10 and negative 9 add to 1 and have a product of negative 90. So that would factor into x plus 10 and x minus 9. So that's the kind of thing that happens when the number at the end is getting fairly large, but the coefficient in the middle for the linear term is close to 0, like 1 or negative 1, or even like 2 or something like that if the numbers are bigger. That can happen too. And that's the end of the tutorial.